Okay, so we're going to talk about quadrilaterals. Quads, right? Think of four-sided shapes. What is a quadrilateral? It's a four-sided closed shape. Okay? The sum of the interior angles is always 360. What was it for triangles yesterday? I hope you remember that. It's 180. For quadrilaterals, the sum of interior is always 360. So here we have a diagram that kind of summarizes the shapes. In the center, like the umbrella of all of the quadrilaterals we're learning, right? We've got just quadrilaterals, and then it branches off into the parallelogram branch. So you can call the parallelogram, it's kind of like an umbrella. Okay? And under parallelogram, that's kind of like the original, right, shape that we're thinking of. We branch off into either you can get a rectangle out of a parallelogram or you can get a rhombus. Okay? What is so special about it? Like if you take a parallelogram which is slanted, it's a slanted rectangle if you think about it. How do you turn that into a rectangle? You just make sure the corners are all 90s. That's how easy that would be. Okay? The angles at the corners are all 90s. That's how that happens. I'm going to use a red pen for that. Okay? So we've got 90s. That's how you would say, how is a parallelogram different than a rectangle? Well, the rectangle, I'm guaranteed to have 90s. How do you turn a parallelogram into a rhombus? I'm sure that you forgot about these shapes, right? You know what's unique about a rhombus? That all four sides measure the same. They are all the same in length. So it's still slanted, but all four sides measure the same. Okay? And then you've got the square, which is a mix. Like if you could put these two together, you get your square. How so, Mr. Dirksen? This square has all four sides equal. And what do we know about the corners? They're all 90s, right? So if you mix a rhombus and a rectangle, you get your square. Okay? And all of these are related to a certain degree. And let's go over to the middle. There's a one loner here. It's called the kite. It's not a diamond, it's a kite. Okay? For some reason, every exam or two, some students are like, what, name this shape? Diamond. And I'm like, no, we never talked about diamonds. It's a kite, okay? Then on the right side, you've got our trapezoids. And a trapezoid looks like this. It's like a chopped off triangle. Think of it as a chopped off triangle. And then you've got the right trapezoid or the isosceles trapezoid. So how many shapes do we have in total? You need to know these names. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 names that you need to know. Okay? Which I will help you with. I have a little thing that you can copy that you can add to your study sheet if you like to have that. What's up with these? Do you see on the sides here, if the arrow goes up, you can say yes, always. But if the arrow goes down on the right side, you can't say always. You have to say, well, sometimes. It depends. What do I mean by that? If a question asks you, can a square be a rectangle? You can always say yes. If you go upstream, you can always say yes. But is a parallelogram always a square? You cannot always say that, right? A parallelogram in and of itself would have to have all sides the same and all 90s and all four corners, right? For you to be able to say that. That's what these arrows mean. So sometimes the province will ask, somebody built a rhombus. Can it be called a parallelogram? And you would say, yeah. A rhombus is always a parallelogram. But you can't say that all parallelograms are squares. You can't, rhombus. You can't say that. Okay? that applies specifically, I would say, more to this section where you have to kind of wonder, is it or is it not, okay? So let's go over to page 26 here. That's where I'm going to add a whole bunch of properties for you. 26. Okay. So you either need to memorize them, or honestly, guys, can you please just think sometimes when you see these shapes, if they ask you something, hey, are the diagonals the same in length? You're like, are they the same in length? No, they're not, right? This and this would be longer than this one. You can even bring a ruler with that day and just be like, that's 72 millimeters, and this one is 58 millimeters, right? So it's actually very obvious that they're not the same. Because sometimes students are like, oh, I didn't memorize, I don't have anything on my study sheet. I'm like, well, you can sometimes just use common sense for these ones. But I'll tell you this anyway. So here, what is a property of a parallelogram? It's got two pairs of parallel sides. And the symbol for parallel is like two slanted lines, forward slashes, if you want to call it. What does parallel mean? Two lines are parallel. What do I mean by that? Say it a bit louder. They're the same, close, but if I walk parallel to someone, will we ever cross paths? We'll never cross paths. We're actually walking alongside each other, okay? So that's what parallel means. And so how we show that on a diagram, I'm going to do it off to the side. If I put an arrowhead in here and in here, I'm saying that those two lines are parallel. If I do a double arrowhead and a double arrowhead here, I'm saying that these two lines are parallel. So that's why it's called a parallelogram. Okay? What else does it have? It has two pairs of congruent sides, or equal sides. You would think, yeah, the symbol is just equal, but for some reason in the world of academia, they use this symbol, which means congruent, like the two sides are the same. But I am okay with you saying equal. The province will be okay with you saying equal in length. That's fine. Another property is that diagonals bisect. What does that mean, bisect? Cut each other in half. Cut each other in half. Okay? Hey, you want to bisect that $10 bill? I don't know. Could you use it? I don't know. You want to split the bill, right? Bisect, that's what it means. You cut each other in half. So another one, you've got one long diagonal and one short diagonal. So this I want you to box in. This is all part of the parallelogram. Okay, that is always true. Can I just, I'm going to do this here in your notes. I'm going to underline long diagonal. And I'm just going to show you that I like color coding here. That is the longer diagonal. And I'm going to use a blue pen for this. You can use a highlighter, whatever you feel like. The short diagonal is the one that, can I just say get a ruler for these ones? Like, I think it's going to help you. Okay? But there's a long and a short diagonal when it comes to parallelogram. As well, I like markings. So if I were to do my study sheet, I would just remember what the markings mean. We've done the parallel sides, we've labeled that, right? Equal sides, we use markings just like a line across. So this one right here, this line, is the same as that one, okay, in length. This one here is the same as that one in length. So these are all properties that the province would expect you to know, okay? For example, guys, as easy as this, I've seen a question where they just give you a picture of a parallelogram and they say, this side is 2 centimeters. What's this side? Please say 2 centimeters, right? That's all, like, don't overthink it. Sometimes it's as easy as that, okay? I forgot one. No, I didn't forget it, I used to not add this. Can I add this as well? 2 pairs. No, sorry, I'm going to rephrase this, sorry. Opposite angles are congruent. That's what I'm going to say. Opposite angles are equal. Okay, sorry, I'm going to add that just so you... What does that mean, opposite angles are equal? If you follow my pen and my pencil here, these 2 angles would be the same. They're opposite. And these 2 angles would measure the same, okay? So if this is 60, this is going to be 60. If this is 110, this is 110. And what do all 4 add up to, guys? 360, right? Remember, it's a 4-sided. All 4 angles add up to 360. Okay, now let's see how a parallelogram turns into a rectangle. So you would say specific. These are specific properties. Specific properties. Like if I asked you, what makes a parallelogram a rectangle? You say everything a parallelogram has plus whatever a rectangle has. So you can see that. That's how I shorten parallelogram. I have the symbol for parallel, and I just go gram. You're like, that's 11 grams? No, 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 parallelogram. Specific properties. All angles are equal to 90 degrees. Okay, let's see if you're paying attention. The diagonals on this one. Would one be shorter than the other? Would they be the same? The same, right? Yeah, okay. Sometimes common sense is all you need. But the diagonals are equal, right? Please remember that. So if the province says, hey, look at this rectangle, and they make a line from here to here, and they tell you that's 10 centimeters, and then they have like A, B here, what's the distance between A and B? That's a diagonal, right? It would be 10 centimeters. Okay, so that's it. You just need to know that. I'm going to leave it there. A rhombus. What makes a rhombus, right? So I will say this. Everything a parallelogram has plus whatever is specific to a rhombus. So I'll say all sides are equal. Boom. You could just say on your study sheet, all sides equal sign. That's it. And this is special here. Diagonals meet at 90 degrees. That is very unique to a rhombus. Can you make sure you know that that's called perpendicular? I don't know what the province might do, but they could do a multiple choice. Which one of these is true about a rhombus? diagonals meet at a perpendicular, if you've never heard of it before, you might say like, I don't know what that is. That must be false, right? No, perpendicular just means meet at a 90. So if you have your, would the diagonals be equal in length on this one? They wouldn't be, because it's pinched. You know what I mean? Like it's slanted. So you still have your long diagonal, and you have the short diagonal. So in that sense, it's the same as the one before. But they meet at a 90. I'm going to highlight this. The fact that diagonals are perpendicular tells me I can go like this in the middle. I can actually say there's a 90 formed between the diagonals. And I know that all four sides have the same length. That's also very unique to a rhombus. Next, I'm going to the square. I would say whatever the parallelogram has, plus what's unique to the square. All angles are equal to 90. So that's kind of the same as a rectangle. All sides are equal. And diagonals meet at 90. What do you think the diagonals, are they same in length, different in length? Same. Yeah, same. So I'm just going to use a pencil here. And they meet at a 90. And all four sides are the same. So the square is the mix between a rhombus and a rectangle. It's a mix of all of these two. Right, boom, give you the square. I'll just highlight meet at a 90 because I want you to know that out of these four shapes, only the rhombus and the square have that 90 in the middle when they cross each other. Okay, let me zoom out here. If the province asks you, do the diagonals bisect? It's right here, correct? I need you to know that all four of these shapes have that property. The diagonals cut each other in half. Okay? It's a little different because this is 10 and this would be 8, let's say. They'd be different in length. So if this is 10, if you were to measure from here to the corner, this would be 5. From here to that corner would be 5, right? The 10 is split in half. The short one, if that's 8, don't put the numbers down because it's going to throw you off. If this is 8, then we know that this is 4 and that is 4. Okay, so that's what bisecting means. It cuts each other in half. So I will get rid of this. I know it's not the most exciting stuff. I know that. I'm trying to make this work here. Diagonals are equal. I'll make that appear on the rectangle just so you see it. There you go. That's it for these ones. Okay, so you must have knowledge of the properties in general for parallelograms and then have the specific ones for the other three that are under the umbrella of parallelograms. Let's continue. Then we've got the trapezoids. Can you just put at the top of 27, just write trapezoids? A trapezoid, you've got two choices. That's it. That's it, two choices. A right trapezoid has, what do you think it's going to have if it says right trapezoid? These two are 90s, okay? They chopped off one of the sides, so it's going to have two right angles right? Sorry. There's two that measure 90, and it's got one pair of, what is that? What happened there? One pair of parallel sides. I think I'm just going to use the symbol for parallel there. So that's it. A right trapezoid doesn't have much to offer. So this bottom base here is going to run parallel to that one up top. Okay. Isosceles trapezoid. The word isosceles should tell you a lot. Okay. It's an isosceles triangle that was chopped off. The top is gone, but the base is still, these two angles are the same. Okay, so let's start with what they have in common. One pair of parallel sides. Let's mark that. It's got two pairs of equal angles. If you could guess, which two angles do you think are going to be the same? What's the first pair of equal angles? The base here, right? This one here is going to measure the same as this one here. And the top here is going to measure the same as this one here. Okay? So one pair of congruent or equal angles and another pair of equal angles. Boom, you're done. And another last one. The diagonals bisect diagonals are, do you think they're going to be equal if you go across diagonals? You always go across, right? You think they're going to be equal or different? What do you think? Equal? Yeah. I can lip read pretty good. Diagonals are equal. Okay. So the diagonals are equal. So if you were to go, they're equal. Okay. Last one, the kite. Do you guys still fly kites? Is that a thing anymore? See, when I was little, in South America, the biggest pastime was flying your kite. So I would use garbage bags, bamboo sticks, and just rags for the tail, and we would make our own kite. Okay, and we would make them huge, like they're probably like my height, like just across and like this, and we had like a roll of string, and we just let it go. Like by the time I was all the way up there, it's probably like this small. You'd like block it with your thumb. So it was fun. So, but then other people would come and fly their kite, and then guess what happened sometimes? The wind brought them together, and then just it fell down, right? And we would be mad at each other. So apparently, I didn't see this happen, but one of the guys had put like razor blades on its tail so that he would like purposely fly close to others, and the razor blades would just cut their kites off, and off they went, right? And so now you will remember a kite forever, right? We didn't have phones back then, so kites were, making it was like half of the work, and then flying them was fun too. All right. What do we know about a kite? These are diagonals here. So the first thing I need you to know is that diagonals, would this mean anything to you? They are perpendicular. That is the symbol for two meeting at a 90. Okay? So you can go over here and say, there's a 90 here, there's a 90 there, there's a 90 there, there's a 90 there. It doesn't matter where you go, there's a 90 at the junction of those two. Okay? Two pairs of equal sides. Okay, there's two pairs of equal sides. So this one up here is the same as this one here. And this one measures the same thing as this one over here. Think of two isosceles triangles stacked on top. The bases were put together, right? So obviously this one is bigger than this one. If all four of these were to be the same, what shape do you have? Not quite a square, it's a rhombus. Yeah, it's a rhombus, so keep that in mind. So a kite is not a rhombus in that sense. So one more thing here. Short diagonal. What is that? Diagonal. Bisects. The short one bisects, okay? So I'm going to highlight that. And I'm going to say we have to use 3 lines, by the way, because we used 1 for this, 2 for this. So the short one is cut in half, but not the long one. Okay? So keep that in mind. And you've got one pair of equal angles. Which two, if you had to guess, would be the same? If I had A, B, C, and D. A and C are the same. Okay? These two are not the same. But this one is the same as this angle right here. So one pair of equal angles. How about we give it a color so it stands out? This one here and this one there. Okay, and that's your kite story of the day. Okay, I don't think you should necessarily copy this for now because maybe you're still wrapping your head around this. But I'm going to give you an example of how you can probably put this all together. I don't think this is the greatest example, but I remember showing this to students. This is what a possible study sheet entry would be. Okay, so you label it, you're under geometry, you label it quadrilaterals. You know you have your parallelograms, which is the umbrella for rectangle, square, and rhombus. Then you've got your kite all alone, and you've got trapezoid, which is, you've got 2 of them. I would say you should have the names, at the very least, you should have the names of this, okay? So it's going to be on the video. If you want to just go to it later and let that inspire you, you go for it. So I just use markings, right? So look at the kite here. If I were to look at this, I would know that, oh, these 2 sides are the same and these 2 sides are the same, right? I know that these 2 angles measure the same. I know that the diagonals meet at a 90 and that the short diagonal is cut in half. The reason why I have 2 diagrams is because if I put everything in one, it's too busy, right? Like it's just too much stuff going on. And so that is an option that I give you. Look at the rectangle. Lots of stuff. I've got the 90s. I've got the fact that these sides measure the same. These sides measure the same. Okay? Parallel, parallel, right? So there's a lot of stuff going on here, but it could help you navigate this without using too much space. And I would argue you could probably compress this even more. Okay? So it's going to be there. Maybe part of today's work time, you use it to put this on your study sheet. Okay? All right. I'm going to, let me see here. I'm going to skip to 30 for now. We'll do the rest later. And I'm going to give you work time. And I will leave the study sheet entry on the screen after. So if you want to copy that, you're more than welcome to do so. Here's, you know what? Can I just quickly, was there a geometry entry for this exam booklet? Let me just quickly find it. maybe we can just do a quick example on this. Probability, vehicle finance, statistics. Here we go. They have polygons, which we haven't done yet, and octagons. So none of this stuff we have covered yet. So we'll just leave it. Okay. So I want you to work through this and use what you know about these shapes that we've just studied. One more thing. Can we go back? I know that you're probably going, why do you do this to us? Can you just go back to page 26 real quick? I want you to know this fact about when there are parallel lines, okay, guys? The sum of these two angles on that side, if you were to take these two angles on this side, should always add up to 180. Okay? The same thing is true about this other side. It's also going to be 180. And I think I'm just going to make my case here that it's true for all of these shapes here. And by the way, a rectangle is 90 and 90, so of course it adds up to 180, correct? So it's not, but you take that, you take the rhombus, if you were to add these two angles, it is 180 here. Same thing on this side, it is 180 there as well. It is the same thing for a square. Okay. Let's keep going to 27. Here's where it matters most. Like this is where it matters. This is where it matters most. Go here to 27. These are a 180. Same with these ones. They add up to 180. Go to the isosceles trapezoid. Also adds up to 180. Also adds up to 180. And the kite, it doesn't apply to. The kite doesn't work for this because you don't have parallel lines with the kite, right? You only have parallel lines up to here. So for the kite, this does not apply. Okay. So that's going to help you working through these questions. Okay. I'm going to ask you to try pages 30. It's going to be a lot, to be honest. I'm going to say 30 to 42 for now. 30 to 42. Okay. I will post the key to this.